Molecular clouds and nebular collapse. Molecular clouds, star formation typically begins in giant clouds of gas and dust known as molecular clouds. These clouds contain hydrogen molecules, H2, helium, and heavier elements. These clouds exist at low temperatures, approximately 10 to 20 Kelvin, and typically have masses ranging from 100 to 1 million solar masses. Nebular collapse. Parts of a molecular cloud can collapse due to external influences, such as supernova explosions or the compression of galactic arms, or their internal dynamics. During the collapse, the density of the cloud increases, and gravitational forces become stronger, leading the cloud to fragment into smaller, denser cores. Formation of dense cores and protostar phase. Dense cores, the collapsing molecular clouds regions become denser, forming dense cores, which are the birthplaces of stars. The mass, size, and temperature of these dense cores are critical in determining the properties of the star that will form. Protostar phase. As dense cores continue to collapse, the material at the center condenses, and the temperature rises. At this stage, the forming object is called a protostar. The protostar is a structure composed of gas and dust within the dense core. As the core collapse continues, the energy released heats the protostar. Birth of a star and determination of its properties. Hydrogen fusion and birth of the star. When the temperature in the protostar's core reaches 10 million Kelvin, hydrogen nuclei fuse to form helium, releasing energy. This process is known as nuclear fusion. Once nuclear fusion begins, the protostar becomes a main sequence star and is considered a fully fledged star. Mass, luminosity, and composition of the star, mass. The star's mass is determined by the initial mass of the dense core and how much material it accumulates during the collapse. Mass significantly influences the star's lifespan, luminosity, and evolution. Luminosity. The star's luminosity increases with its mass. More massive stars produce more energy and are brighter. Composition. The composition of stars is determined by the chemical makeup of the molecular cloud. They primarily consist of hydrogen and helium, with trace amounts of heavier elements.